At ESA, the European Space Agency, space is our business. It's a place we explore, heading outwards while also looking back to improve life on our own blue planet. Here's what you need to know about the stuff that surrounds us. Planet Earth, with its air, comfortable gravity, and life, is unusual. Most of the other 99.999999999999999% of the universe is just space. If your car could drive vertically, it would reach the altitude where the lowest satellites fly within a couple of hours. If you go straight up, gravity will only pull you down again. The gravitational pull at the orbit of the International Space Station is still 90% of that at Earth's surface. Going into space means moving horizontally, but doing it very fast, 400 times faster than a car, to about 8 kilometers per second. So when rockets lift off, you really see them turning sideways, not flying straight. Earth's gravity is still pulling on you, but you're moving so fast you fall around the world instead of hitting it. This is called an orbit. The orbit you need depends on what you want to do in space. A lot of our work comes down to improving life on Earth. Fly close for sharp-eyed environmental monitoring, higher orbits for navigation satellites covering more of the planet at once. The farther you orbit away from Earth, the lower gravity's pull, so the slower you fly to overcome it. Weather and communication satellites are in geostationary orbit around the equator, keeping pace with Earth's rotation to stay at a single spot in the sky, looking at the same place on the ground. Earth orbit is only the start. With a big enough push of power, you can escape altogether. This shifts you to solar orbit, free to go to other places also orbiting the Sun, the other worlds and planetoids of our solar system. To go into orbit, that takes rocket power, basically a controlled explosion in a single direction. ESA oversees a family of launchers maintaining Europe's independent link to space. To shift orbits requires firing much smaller versions of rockets, called thrusters, fitted aboard spacecraft. Before flight, we have to test spacecraft on earthquake-strength shaker tables, as well as blasting them with noise to check that they can endure launch conditions. Space is also a place where you can be hot and cold at the same time, depending on whether you're in sunlight or shadow. During testing in a vacuum chamber, each new spacecraft experiences extreme hot and cold to make sure it won't overheat, freeze, or buckle. Space is also radioactive, filled with energetic charged particles spewed out by the sun or deep space. To reduce any risk of disruption or damage, spacecraft components need testing using nuclear isotopes or particle accelerators. ESA also keeps a watch on space weather because solar storms can damage terrestrial power and communication links, as well as satellites in orbit. Radiation is one reason the International Space Station orbits at just 400 kilometers up to shelter inside Earth's magnetic field. Astronauts still wear radiation badges to check their exposure. Space is endless. When the Hubble Space Telescope did a long exposure on a dark patch of sky, it revealed myriad galaxies in the black. And space is still growing, expanding at an ever-accelerating rate. Why go out there? Because space is useful and valuable for watching over our home, navigating across it, and connecting everyone. Because it's the place we all live, so we should explore space while staying on guard against hazards like solar storms, space debris, and asteroids. That's why ESA does what we do. because Earth is only the start.